Okay. Can I proceed, sir?
Yes, sir. Yes, proceed.
Okay. So I start from the basics and I will go to the advanced level. So there are three components are there in my presentation for another 90 minutes. So first I will focus the area of text mining. That is, I will introduce this particular subject, I can say like that. And later I am going to discuss on how mathematics helps me to do text analytics. For that, I am going to take I'm going to cover some of the concepts in NLP, that is natural language processing, for doing the text analytics. And finally, how a model, mathematical model is created for any given document. And one kind of an analytics that I'm going to discuss today is similarity analysis, right? How to compare one document with another document and how to predict how close are these two documents. So after discussing this particular thing, there are n number of applications are there, right, with respect to this kind of similarity analysis. So according to your own vision will, you can focus your research in this particular field. There are several mathematical models are there, but here I am going to touch upon cosine similarity. That is a mathematical model. Apart from that, there are a lot of distance equations are there. Manhattan distance is there. Mahalanobis distance is there. KL divergent is there. Jacket distance is there. There are a lot of things are there. So according to your application, which one is suit for you, you can take it. So the next thing, and at the same time, I'm going to give an demo, right, using R programming with respect to how to perform cosine similarity analysis. And if time permits, I will touch upon how to perform document classification. That is the core research area of mine. So we touched most from the machine learning algorithm to the advanced deep learning models. We covered everything, and we also come up with some new algorithms too. I will share all these things at the end of my presentation. Okay, so that's all. This particular slide will capture everything to you about the topic called text analytics. First, what I am going to do is how to represent the text, right? That is a thing I'm going to focus for another 15 minutes. That is called document representation. A text or a document, both are same, synonym in the field of text analytics. So how I am going to represent the text, right, in computer? That is a major thing. So after representing the text, right, usually I'm going to go with a representation of vector representation. That model is called vector space model. That is a basic model. So nowadays, the people are using word embedding techniques, right? There are several word embedding techniques are there. I have to say like this: word to vec, and document to vec, fast text, GloVe. So these are all the various advanced models are there for representation of a document. But today I'm going to discuss the vector space model only, because due to the unavailability of time. So if I'm going to talk about all these model, it will take 3 hours for me. But today I'm going to focus only on vector space model. So once the document is represented by means of a vector space model, then I'm going to explain you these two things, that is cosine similarity analysis and document classification using the classical machine learning algorithm called Navy Bayes algorithm. So these are all the two things I'm going to focus today. So with respect to core linear algebraic formation, I'm going to explain cosine similarity. With respect to machine learning algorithm, I can say I'm going to use the supervised machine learning algorithm Navy Bayes for document classification. Cosine similarity for similarity analysis. Okay, so I can divide my talk in part 1 and part 2. First, I will finish the part 1 within 30 minutes, and if time is there and more time is there, I will give some more priority to how to perform document classification. Okay, I already explained some background information about the data, so I don't want to do some kind of duplication or redundant information. So in a computer science field, a data may be a structured, semi-structured, or unstructured. But here my topic today is text analytics. So yesterday we come across with a lot of data sets, right? So all the data sets represented in terms of rows and columns. So I called the data sets are structured data set. But here today I'm going to deal everything with unstructured data, unstructured data, that is text. Okay, that is a free text. That is a free text I am going to focus. So why I am more interested in unstructured text? Because there is a rapid growth of text information. If you compare to structured data, there is an enormous growth of textual information. Say wherever if you open www, right, you can get a terabyte and petabyte of text information. Similarly, from desktop, email, intranet, blog, literature, newspaper, right? So these are all the various sources from which I can get the text information. And the most important thing I want to say, if you compare the amount of data that is available in this digital world, that is compared to text data and structured data and unstructured data, I can say, so 90% or 80% of data is mostly in the form of textual in nature. So that if you are going to focus your career, right, towards this text analytics, and surely you are going to have your very good bright future in as a data scientist. Okay, so what we are going to do in text analytics? Okay, so here I'm going to analyze, I'm going to organize, and I'm going to summarize certain things according to my application. That is the thing I'm going to do in text analytics. If I want to put it everything in a nutshell, so this particular slide will explain you everything. So the input to any text analytics projects, it would be some documents, some input documents will be there. Then what I'm going to do with these documents, I can find is there is any pattern, hidden pattern is there inside all these documents. And I can also find out any connection between all these documents, right? And at the same time, I can do some kind of profiling over these documents. And at the same time, I can do some kind of trend analysis with the documents. With respect to any kind of application domain, the documents may differ. Say, for example, if you take an insurance industry, it has its own collection of documents, and you can do all this kind of an analysis. You can take any particular financial sector, you can do the same kind of analysis with its own objectives. So I'm saying, so text analytics is a very nice area to choose, right, for you people. If you are really interested, you can choose. Otherwise, you can go with your own things. Then, what is actually a text analytics? I can say in this way, right? So I'm going to define this text analytics as per the Camber's definition, right? Usama Fayad. Okay. What he says, a text analytics means we have to do some kind of analytics in such a way that the information you are going to find, it should be non-trivial. That is very, very important. It should not be trivial information. And at the same time, if you are going to do some analytics, you have to find some hidden things, not the information which is readily available, readily viewable. It's not important. And at the same time, that information should be previously unknown, right? Then only you have to do analytics. And most importantly, that information should be useful. So after doing the analytics and it is meaningless with the knowledge, then it is useless. So if you are going to do all these kind of things in this analytics, then only that particular activity is going to be considered. Okay. Yes. Why dealing with text is always tough? Yes. So text analytics, I can say it's a very toughest activity. Why? Because it is very, very difficult to visualize the concepts. I mean, I'm saying that depending upon the words. Say, for example, English has its own collection of words. Malayalam has its own collection of words. Tamil has its own collection of words. Similarly, the international language like Spanish, right, French, it has its own collection of words. So obviously, it's a text is an high dimensional data, right? So we cannot restrict the number of words. Okay, so that's why they are saying, the most of the authors are saying text analytics is a toughest thing. But text analytics is very, very easy. Why? Because if you take any document, you can find most of the data are in redundant in nature. So once most of the data is redundant, we are having a wonderful computational techniques to remove all this redundant data. So that is the thing we are going to focus today. So from a document or a text, how to remove the redundant data, right? And most importantly, if there is a passage of paragraph information, right? Only certain phrases are important, right? So if you are able to pull out that important phrases, and if you are going to do the analytics, then you can easily find out the knowledge. Then you can easily establish the hidden patterns, or easily you can find out the trend. So that I can say the text analytics is very, very easiest task. Yes. So once if you are ready to go with the text analytics, right? And if you are very much interested in doing text processing, so these are all the fields you have to familiarize with, right? I can say first and foremost, it's natural language processing, right? It will having several genres with respect to how to handle the computational linguistics, right? With respect to any particular language, and most importantly, machine learning. I can say the another field of interest is information retrieval and semantic web. So if you are having some kind of an idea with this all these kind of subjects, then it is very very easy for you to do text processing. Yes. Now I'm directly going to text analytics process. Okay. So this is the overall architecture diagram of the text analytics. So I think in this, after seeing this diagram, if you already learn this particular course called data mining, right? You come across with the same kind of architecture diagram. I inherited the same diagram here with respect to text analytics. See here, what would be my input? My input would be a raw text. So I already said that the text will have a lot of redundant information. So what is the next activity I have to do? I have to pre-process. So in all data analytics process, we will do data pre-processing, but here we are going to do some text pre-processing by taking the knowledge of NLP and information retrieval field, right? So once the text is pre-processed, right, then I have to do some kind of transformation. Why I have to do transformation? Because in order to provide some uniformity to the data, that is the purpose I am going for transformation. So I think in data mining, you come with a normalization technique, that is the thing I am calling it here, text transformation. There are several kind of normalizations is available. Say, for example, min-max normalization, z-score normalization, like that. So you can go with any kind of, any one of the normalization for doing text transformation. Okay, after performing the text transformation, we will have several features. So it is not necessary. Yesterday also I told that. So whenever you are having an n number of features, it is not necessary to take all the n features to do the analytics. You can take the subset of features, right? For that, we have to rely on some feature engineering technique. So that is called feature selection, right? So according to the feature engineering technique, among the n features, we are going to take some subset of features. So after selecting the features, then I am going to build some models by using machine learning algorithm or data mining functionality. Either it may be you can apply a supervised learning algorithm, or you can use an unsupervised learning algorithm, right, for building the model, right? So after the model is built, so you can test the model with some new data, and you can interpret the value, and you can give it to the decision maker. So this is the entire overall architecture of any text analytics process. Now I'm going to explain each activity one after the other, right? And finally, I will interpret the result into, I can say that is an evaluation procedure. Okay, so here I already told that I'm going to use information retrieval technique style for doing text analytics, for which I am going to take the concept of vector. So, and the model that I'm going to create is called vector space model. Otherwise, some author can say bag of words model. So that model only I'm going to touch today. Okay. So for doing that kind of analytics, so what are all the NLP and the information retrieval techniques that I'm going to adapt? Are stemming. I will explain you what is stemming. Stop words. So I said that any particular language, either Malayalam or English or Tamil, has its own stop words, right? Okay. The stop words means the word which doesn't have any importance to it. It is called stop words. With an example, I will explain you very soon what are all stop words and how to do stemming, everything. And finally, how to give the weights to the words, that is called terms. So the terms and words are synonym to each other in text analytics. Then how I am going to assign the weights to the words? Because in text analytics also, I am not going to do any kind of analytics with the alphabets. All the words are going to be converted into some numbers. With the numbers only, I'm going to do some analytics, right? So in unstructured data also, if you are going to do some analytics over unstructured data, so that unstructured data should be converted into structured one. That means in terms of numbers. Once if it is converted into numbers, then I am going to do some analytics over that. That is called TF IDF. I will explain what is TF, that is term frequency, and IDF, that is inverse document frequency. How to compute term frequency and inverse document frequency of any given document, right? And finally, I'm going to represent the document through by means of vector space model, right? And I will show you how to do some kind of similarity analysis using the linear algebraic formation, for example, cosine and KL divergence. That is my thing. Right. Now I am very specific to my problem domain. So what I'm going to do, I'm going to take the raw text. Then I'm going to apply stemming and stop words to the raw text. So I will get some textual information. I will get some text. I'm going to do some kind of tokenization. Tokenization means splitting the sentence into words. I can say like that. So next, after performing tokenization, I'm going to assign weights to the words. So once the weight is assigned to the words, it becomes numeric, right? So for each document, for each terms, I'm going to assign some weights, some numbers. So if you take M documents, automatically I'm going to have M rows. And in all M documents, if I'm going to have N words, I'm going to call it terms, N terms. So now slowly you can see it is in the form of matrix, right? So the row constitute number of documents and column represents all the words, right, in the given documents. So slowly it becomes a two-dimensional matrix. Okay, so once the two-dimensional matrix is given to me, then it is very easy for me to perform any kind of analytics. But here I'm going to do similarity analysis and I'm going to show you the classification procedure. Yes. Now I'm going to inherit the concept called as vector space model for document representation. So for another 10 minutes, I'm going to explain you how a document can be represented using the mathematical model called vector space model. Yes. The most common way to deal with the document is first to transform them into sparse numeric vectors. I already told that, because once if you are having some sequence of words, it's not necessary to do any kind of analysis, right? So I'm going to convert everything into numbers. So once if it is everything is converted into numbers, then it is easy for me to apply all the linear algebra operations. But here, the most important thing is we are not going to focus on linguistic information of that particular text. Okay. So we are not going to check over with respect to semantic. We are not going to bother about semantic. Okay. Slowly I will explain everything to you. Right. So some author can say it's a vector space model, and some of them can call it as a bag of word model. Okay. Yes. So in this vector space model, each word in a dimension, each word in a document is called as a dimension. Okay. This is a theory part. I will directly go with a running example so that you will have some better understanding. So just have some kind of an assumption. So what is mean by dimension? Dimension means a word, right? And a document may have several dimensions. See here, there is a document D, I can say, which consists of M words. So I'm saying it's a M dimension document. Okay. So that is a thing. Okay. But if you take any language, right? It's English or Malayalam or Tamil, anything. There are so many words are there. So the dimension should be infinite, right? But and at the same time, how to determine the importance of the word? So which word is important? Which word I have to take for analytics? So these two problems comes immediately to me while representing the text through by means of numbers. But I can easily tackle these two problems by using the techniques called stopword and stemming. So by using the stopword and stemming, I can easily handle this particular problem. There are so many English words I can said, So these so many words can be reduced to smaller things by using the techniques called stopword removal and stemming operation. I will explain you with a running example, don't worry. And the second problem, how to determine the importance of the word. So that problem is handled by TF-IDF schema definition. That is, by calculating the term frequency and inverse document frequency, it is very, very easy for me to assign which words are important for my consideration. I can easily find out. Okay. And these are all these formulas you have to know while converting a text to numbers. See here, what is mean by term frequency of a word? How to calculate a term frequency of a word in a document? It is just number of times the word, that particular word, appears in the document is called as term frequency. I will explain you everything with a running example. Right? Then what is called inverse document frequency? It's a mathematical formula, right? So inverse document frequency of a word is calculated using the formula log of total documents divided by document frequency. Surely if you are going to do some kind of an data analytics, you know how many documents are there. So that value is total documents. And you know the document frequency also. The word, number of times that word appears in all the documents. This is called document frequency. Term frequency is different. Document frequency is different. Okay. I will explain you everything to you with a running example. And finally, after defining TF and IDF, then I have to assign weight to the words. So the formula is just multiplying the term frequency with the IDF, we can easily find out the weight of the words. So once if the three formulas is known to you, then you can easily transform the linguistic structure of a text to a numerical form. Let us see with a running example. Okay, so this is the way in which the text is going to be changed. Say for example, I am going to take a running text like this. Okay, running text like this, and after doing all the analytics, it's going to be converted into numbers. Right? Some words can be removed. Right? And most important words are captured from this document. And for all the words, I am going to assign some numerics. That is called vector representation. Otherwise, they will call it as a bag of word representation. So if for a given document, if there are more number of words, then automatically it will have higher dimension, right? So if you consider that matrix, most of the time the matrix will be in type of sparse in nature. Sparse means most of the entries will be zero. I will explain everything to you with a running example. Okay, so that's all about the theory behind the document representation related to text analytics. Now, I am going to take some documents and I am going to do some activities. So, I want to, at this juncture, I want to thank Professor TV Geeta Madam, right, who beautifully explained all these concepts to me in one particular workshop. So that thing I'm sharing right now to you, right? So I really thankful to TV Geeta Madam. So I think it's a right juncture for me to refer Madam to have a wonderful example to explain the text analytics process. The same thing I'm going to explain to you people. I think you will have some better clarity. All right. Now, actually, the time is 10:25. If you observe my lecture for another 15 minutes, right? So you will understand clearly all the basic things regarding document representation. So I request all the participants to focus with my lecture. Okay. So if you want to do text analytics, first task is you have to represent the document in terms of matrix, that is vector. Okay, fine. How to do that one? For that, you have to do some 9-step process. Now I am going to explain each steps involved in converting the document to matrix format. Okay. See here, that is step 1 is extraction of text. That means, see here in this problem, I am given with 3 documents. See here, you are seeing 3 documents. The first document contains only for a example purpose, I have made a simple documents, right? But real time, the document consists of n number of words. Okay. Okay, fine. So the first document contains the information. This is a data mining course. The second document, which contains the information, we are studying text mining. Text mining is a subfield of data mining. And my third document is mining text is interesting and I am interested in it. So 3 documents I am having. Now I am going to convert this 3 document to a mathematical model. That mathematical model is a vector space model. Yes. So the first step is extracting the text. That is, you have to remove the prepositions. The preposition means full stop, comma, like that. Okay. So from this document, on applying the step 1, this document becomes like this. See here, the full stop is get removed. See here, we are studying text mining and this full stop is get removed. Right. Here, comma and full stop is removed. So though now after performing this particular activity, all the sentences becomes only group of words, right? The entire paragraph in this, all the paragraphs in a given document is going to be converted into sequence of words only. So that is the objective of step 1, that is extracting the text. That means I am removing the all the prepositions which are present in the text. The prepositions I can say here, comma, full stop, apostrophe, like that, question mark, like that. Okay. I think step 1 is clear for you. And step 2 is stop word removal. Now I can explain what is stop words. See, dear participant, stop word means there are words in each language which doesn't use any specific meaning, right? Such words are called stop words. See here, if you consider the document 1, this is a data mining course. The words, this, is, yeah. So these are all the words which doesn't have any specific meaning. That words are called stop words. But you will ask this question. So how to know for any given language, what are all the language are called as stop words? For that, we are following the standard is Stanford University stop word. They listed out. So this much of for an English language, this much. These are all the stop words like that. So similarly, each language has its own defined benchmarked stop words. Malayalam has its own list of words which comes under stop words. Tamil has its own stop words, right? So, but in Python and R, you can easily use certain packages to remove the stop words. I will explain everything to you, right? I think now you understand how to remove stop words, right? See here, we are all stop words, so I removed. Then is a is a stop word, I removed. Off is a stop word, I removed. Now this document is converted into like this. So in the left hand side, you are seeing the original documents. In the right hand side, you are seeing what are all the steps that I'm carrying out, right? Fine. So that's all about step 2. Next, the third step is very simple, because in a document analysis or in a text analytics, there is no importance to uppercase letters. So the step 3 is you have to convert all the words, right, into lowercase, right? See here, this document, there is no uppercase because data mining course is my important words so far, terms. So it doesn't have any capital letters. So no way to apply the step 3. But here if you see, right, so there is a word called text which having capital letter, right? So I converted into small case. That's all. So that's all about step 3. And step 4 is called stemming. Stemming means finding the root word of any given word. That is called stemming. Here also for the English language, we are going to follow Stanford University Stemmer, right? So there are some predefined packages are there to perform stemming. That is how to find the root word of a given word. Say for example, in this document, so after doing step 1, step 2, step 3, I came with data mining course. While applying to step 4, the data, the root word is data only. The mining, the root word is mine. The course, the root word is course only. For the word studying, the root word is study. Text is text only. Mining, mine. Text is text only. Mining, mine. Subfield, root word is subfield only. Data, data only. Mining, mine word. So in this fashion, for all these words, you have to find the root word. That concept is called stemming. So next step is counting the word frequency. Word frequency means term frequency, I'm saying. See here, slowly, I'm representing the document to a vector form. See here. So this particular document, which consists of data, mine, course. Now for each words, for each terms, I'm going to assign some identifiers. Okay. And at the same time, I'm going to arrange them alphabetically. So in this document, data, mine, course, or 3 words are there. I'm going to arrange it alphabetically. So the course comes first. The term, the word course comes first. So that I have put for identification purpose X1. That is, it's a term. So the next is alphabetically data comes X1. That is an identifier. Next is mine, identifier number, identifier, right? That's all. So likewise, we are having this much of words. 1, 2, 3, 4, 5, 6, 7, 8 words are there. I am going to count the word frequency. Study how many, sorry, which one comes first? First comes is data. How many times the data is here in this document? Only 1 times. Okay, 1 times, right? X1, that is called word frequency. Mine, how many times here? So in this document, the frequency of mine is 3. 3 times it comes. So that I have put mine X3. That means the term mine comes 3 times. Similarly for the other words also. Okay. I think you understand the concept of how to calculate the word frequency or term frequency of a word with respect to a given document. Kumar sir, whether I am making sense?
What, sir?
Whether I am making sense, sir? Okay.
Okay, sir. Continue.
Fine. So now slowly I am making certain things complex. So the 6th step is how to create an index file for any given document. So here I am going to calculate the document frequency. In step 5, we calculated term frequency, that is otherwise called as word frequency. In step 6, we are going to calculate document frequency. See, document frequency means you have to take a word and you have to check how many times it appears in all the documents. Say for example, so altogether in these 3 documents, I come up with some 7 words only in this example. So I made it as a file. Course, data, interest, mind, study, subfield text. So these are all the terms. These are all my words. Now I have to find the document frequency of all the words. So course, how many times? Only 1 times in document 1. So 1 document frequency is 1. Data, how many times? So data appears in document 1 as well as in document 2. So the document frequency is 2. Similarly, interest, it occurs only in document 3, 1, mine. So mine is a word which occurs in document 1, document 2, document 3. So the document frequency is 3. Similarly, I can find out the document frequency of all the words. So this is my 6th step. Now, I am going to convert that textual information to numeric information. It's simple. I said that how many words are there? 7 words are there. So 7 dimensions are there for me. So that is called a vector, right? Now, after finalizing, there are 7 words are there which spans across all these documents. So my length of my vector is 7. Okay. So now I am going to assign I am going to map with respect to the corresponding value. Say for example, this is course, whether it is there, yes, it is there. So it is the first row, first column, that is value is set to 1 because that word is there in document 1. Okay. And data, I am checking here. Yes, that word is present in document 1. So it is 1. So interest, I am checking. No. So 0. Mine, is it is there? 1. Study, no, 0. Subfield, no, 0. Text, no, 0. That's all. This is my first vector, first row of information, right? So now see, the vector is formed. The vector is formed. Okay, now I am coming to second document, right? I am going to do the same check operation. Course is there? No, 0. Data is there? Yes, data is there one time. Interest is there? Yes, interest is, sorry, no, there is no interest. So it is 0. Mine is there? Yes, mine is there, right? How many times it is there? 3 times is there, right? So that I am writing 3, right? Study is there? Yes, study is there. Subfield is there? Yes, subfield is there. Text is there? Text is there. Okay. How many times? 2 times is there. Okay. So that's all. In this way, a vector is formed for each document. Okay. Now I am going to give the weight of the word. I said that in order to find the weight of the word, I have to find out the inverse document frequency, right? So how to calculate the inverse document frequency of all the words? It's very simple. Previously I told the formula log of total documents divided by document frequency. So that is a formula for calculating the IDF. Let us see how to calculate the word frequency, IDF of all the words. Let's first take the word course, right? Now I'm going to find out the IDF of the word course. So I'm going to substitute in this formula. So IDF of course equal to log of total documents. I'm having 3 documents. So log of 3 divided by document frequency. What is the document frequency of the word course? It is 1. So log 3 by 1. So log 3. If you check the logarithmic table, so the answer for log 3 is 0.477. Similarly for all the words, right? Say for example, I will explain for data. So IDF of data equal to log of 3, that is total document. There will not be any change with total documents. Log 3 by document frequency. Document frequency is 3 by 2. So log 3 by 2, the corresponding value, if you see the logarithmic table, the value would be 0.176. So in this way, I have calculated the IDF of all the words. Once the IDF is calculated, and here the term frequencies are there in form of vector, so the next step is computing the words. I said that the weight of the word is computed by just multiplying the term frequency with the IDF. So I said that this red color values in the vector are called term frequency, and here I calculated the inverse document frequency. I am just going to multiply the term frequency with the inverse document frequency of the corresponding words. Say for example, it is 1. 1 meant course. That is term frequency. It is to be multiplied with IDF. That is 0.477. So the answer is 0.477. So the value which is in blue color is the weight of the word course. Similarly for the remaining entries, just multiplying, right, the values in this vector with the corresponding the values with respect to IDF, right? That's all about computing the weights. So now the weights are calculated, but there is no uniformity is there. So in order to establish uniformity, I have to normalize. So I have to normalize to unit length. So to normalize all the documents, the general formula is, so weight of a word equal to weight of a word divided by square root of w square of word 1 plus w square of word 2 plus etc. the nth word, right? This is the general formula for finding the weight of the word of a particular word. So let us take how to calculate the weight of the word for how to normalize the word weight for the word course, right? Let us take weight of course equal to, that is weight of word. What is the weight of word? It is actually, previously it is 0. Can I proceed? 0.477 divided by square root of, that is you have to square the value of weight of first word, second word, third word, fourth word, fifth word, sixth word, seventh word.
మేము ఇచ్చిన కోడ్ 91 కదా.
చంద్రశేఖర్ సార్, ప్లీజ్ మ్యూట్ యువర్ మైక్.
లిస్ట్ సార్, సీరియల్ నెంబర్ సార్. కేఎల్ యూనివర్సిటీ గుర్తుంది 99 సార్.
Chandrasekhar, please mute your mic.
So can I proceed?
Wait, sir. Wait. Somebody unmuted. Chandrasekhar Kohli, please mute your mic. Chandrasekhar. Chandrasekhar, please mute your mic, or else I will remove from your this meeting. Okay, sir, continue.
Thank you, sir. So we are standing in the final step, that is how to normalize all the documents to unit length, right? So it is very simple, a simple mathematical formula. You have to take the weight of the word in the numerator and you have to sum all the squares of the weight of the words in the all the documents. If you are going to do that, you can easily normalize the weights to unit length. So ultimately we come across with the three vectors. So this vector relates to document 1, this vector relates to document 2, and this vector relates to document 3. If you arrange it, it will be in the form of 3 by 7 matrix, right? 3 by 7 matrix. So once the matrix values are there, then you can apply the linear algebraic equations to do some kind of analytics. That's all. The most important thing in text analytics is you have to convert the document to some form of standard usual representation. There are several representations are there. So vector space model or bag of word model is a one particular thing. Okay. See here. Now I am going to explain you the analytical parts. Right now, so far, I have taken some documents. And I have represented the documents in form of vectors. Right now, my role is to do some analytics. So I
Sir, I have a question, sir.
Yes, madam, please go ahead.
Sir, I missed the point how you got the 0.938. Can you just tell that, sir?
Yes, madam. Madam, here I got 0.938 by normalizing all the documents to unit length. That means I have to take the weight of the word course. What is the weight of the word course? So it is TF into IDF, I multiply this thing, that is 0.477. So you take it in the numerator 0.477 divided by, take all the weights. Okay, madam? Weight of word 1, weight of word 2, just multiplying. Okay, with respect to first one. Madam, do you understand, madam?
Now I understand, sir.
Okay. Just square and sum all the words, right? With respect to its corresponding value. See here, that is 0.47 the whole square plus 0.176 the whole square plus 0 plus 0 plus 0 plus 0 plus 0. If you do summation and if you are going to carry out this division operation, you will get the value 0.938. Madam, is it okay?
Okay, sir. Then for 0.346 also the same way.
Same way. You have to take
And
the data, right? You have to take, what is the weight of the data? It is 0.176. You take that one in the numerator and you do it for all this. The denominator, there will not be any change. But numerator only I am going to change. Similarly, I will find out, this is called normalization, madam. I think
Okay, sir.
it's a basic, simple normalization technique. It's not a, it's not a rocket science, madam. Okay,
I
madam?
understand. I understand.
Okay, thank you. Thank you
Thank
very
you, sir.
much.
Thank
Okay.
you, sir.
Sir, can I have one more question, sir?
Yes, please go ahead.
Sir, normally TF-IDF is used for semantic
Yes, but not.
document.
Yes,
Talking about bag of words.
yes. It's a bag of words means it doesn't look for what semantic, but TF and IDF somewhat you will consider what semantic, not the core level of semantic you are not going to take. For that purpose, only word embedding techniques comes into existence. Is it clear?
Yeah, sir.
Madam, if
Not
you
complete.
are going for bag of words representation, you are not
Yes, sir.
going to bother about semantic. Okay, madam? You are still
Okay, sir.
going with syntactic only. But if you are going to consider TF and IDF, you are taking some 60 to 70% of semantics into consideration. Okay, madam?
Yes.
But
Yes, sir.
if you
Yes,
are
sir.
going for a technique like word embeddings, then more than 90% of semantics is considered. Okay, madam?
Oh, yes, sir. Yes, sir. Yes, sir.
Okay.
I understand.
And
Yes, thank you.
really, if you want to explore several things, please study by yourself the word embedding techniques. I think these
Yeah.
fundamentals, with these fundamentals, you can learn anything, madam. Okay.
Yes, sir. Yes, sir. Yes.
Okay.
Thank you, sir.
Okay. Okay, now we represented the document. Now our next step is to do some analytics, right? So here there are several things we can do with this kind. Once a document is ready in terms of a matrix, you can do several analysis. But today I am going to explain you the some areas of analysis like similarity analysis and classification. Okay, so this is the linear algebraic formation that I am going to take for similarity analysis. So it is a well-defined one. Even if you want to check the similarity between the documents, most of the authors will prefer cosine similarity only, right? So this is the formula for comparing the two documents with respect to cosine similarity, right? Say for example, here A and B are the documents. So the cosine similarity is represented by cos theta. That is, if theta comes, automatically some angle should be there, right? See here I'm having the vectors A, I and BI. So here in this example, my I spans from document 1, document 2, document 3. So there are 3 documents are there. So my sigma I equal to 1 to 3, right? For all the documents, right? So, but in pairwise only you can do similarity analysis using cosine similarity. So this is the generalized formula, right? For calculating the cosine similarity. Okay. So after taking 2 vectors, say for example, this is vector number 1, this is vector number 2, that is this is A and this is B. And if you are going to give these 2 vectors over in this particular equations, you will get some value. And if you find the cos theta of that value, it will give some angle. And if the angles are parallel in nature, then you can say the document are similar. If it is orthogonal in nature, then you can say the documents are completely different. So that kind of interpretation you can go with. Don't worry, dear participants, I will explain you all these things with some codes. Okay. Yes, see here. I run, right, this particular activity, right? So whatever activity we have performed, I run using R, right? Okay, so here is the result, right? See here, I have taken 3 documents. Okay, so this is the document term matrix. I can say like that. Why I am saying document term matrix? Because in row you will see documents. Document 1, document 2, document 3. In the column you will find the terms. How many terms are there? 7 terms are there. Because here, see here, 7 terms are there. 7 terms are there. The corresponding vectors. These are all the corresponding vectors. See, these are all the corresponding vectors that I have derived. So I am going to take it in terms of matrix. So this is called usually document term matrix, right? So I think I don't know how many of you know the syntax of R programming. See here, I am using latent semantic analysis library function in R. So I am defining a vector. So the C function, C of is the function which is used to define a vector. So I defined a vector, right? A row vector, and I store it in a variable A. And for the document 2, right, I created a vector. Document 3, I created a vector. And by using the library function cosine, right, I'm calculating the similarity between these 2 documents, A and B. That is, this is a data mining course and this document, right? I'm finding the cosine similarity and you are seeing the value. So the output, right, the output is here you are seeing it is 0.077, right? That is 77%. I think these documents are close to each other. Similarly, if you want to do the similarity, right, for all the documents, right? So I binded all these values using the cbind function, right? And I am going to calculate the cosine value of the data, right? So this is the corresponding matrix, right? See the document A with the document A, actually it's more or similar. So similarity is 1. So if you compare A with B, it will give 0.077. So the similarity between document A and C, so there is no similarity. So document B and A, same thing. B and B, 1. B and C, right? We are having 0.81 like that. So that's all about similarity. So now for your application, what you can do, you can take the tweet messages and you can do some similarity analysis, right? So how the tweet of a one person is similar to other person. Otherwise, whenever you are getting the answer papers from your students, you can do some similarity analysis, right? So n number of applications are there. Say for example, if it is a medical domain and if there is a prescription made by the doctor, then you can do some similarity analysis with respect to patients' data. See the application, there are n number of applications. You have to find out. So where you have to apply all this kind of logic. Okay. So that's all about document similarity analysis. So here I can interpret like this. The cosine similarity between document D1 and D2. That is document 1 and document 2 is 0.0778761 like that, right? But please you have to note cosine function in R only works with respect to square matrix of any size, right? And the cosine function will not work on matrix, but it only works on data frame, right? But there are some library functions are there in R programming to convert the matrix to data frame. So once if you convert the matrix to data frame and if you apply the cosine function, then it will give a beautiful result and you will go for a good interpretations. So that's all about document similarity analysis. I said that, so it is theta, right? So for all the documents, you can also visualize like this, okay, by means of an angle. So see here, by calculating the angle between document 1 and document 2, I think it will be some 10 degree. So that shows the similarity. So if it is orthogonal in nature, then automatically the documents are not similar in nature, right? So such kind of conclusion you can derive. Say for example, document and document 3, right? If you measure the angle, if you measure that, it will be more value. So the documents are different in nature. In this way, you can interpret your result by using cosine similarity. Okay, so for another 30 minutes, I think I can focus on classification, text classification. Otherwise, they will call it as a text categorization. So text categorization means, say for example, I am having several documents. Now I am going to assign labels to each documents. See here, there are several documents are there. Now I have to build a system. I have to build a categorization system in such a way that for all the documents, I have to assign some labels. So after doing analysis over this document only, I have to fix a label, whether the document speaks about sports or whether the document speaks about business or educations or politics like that, right? That is called text classification. Okay, say for example, we are getting mail, we are getting mails from to our inboxes. Automatically, the mail system will do some classification, whether the mail is ham or spam. That kind of classification is performed, So now I'm going to take the same thing and I'm going to execute with you in our programming language, how to do document classification. That is how to determine whether the message is ham or spam. That is the thing I'm going to explain you right now. So for that you have to rely on machine learning algorithms. So especially supervised learning algorithms, right? If I'm going to say supervised learning algorithm, at the top, support vector machine gives a better result than logistic regression, and using neural networks, Navy Bayesian classifier, random forest is there, KNN is there, that is K nearest to neighborhood algorithms are there. If you are master in all these algorithms and if you know all the mathematics behind all these algorithms, you can contribute to this algorithm, and you can improvise the result, right? So just applying the library function of Python and R, it will never support the research, right? You have to optimize. You have to optimize in such a way all these algorithms, and you have to interpret the result. Then only the research community will accept. Okay. So that's all about classification process. Now I think I can give you some kind of demo. Kumar sir, can I give a demo?
Yes, sir. Yes, yes. It is R, na? R or Python?
R programming.
Okay, okay.
Okay.
Okay, sir.
Okay. So before that, I will explain you something related to document classification mathematics. Mathematics became document classification because yesterday one of the participant asked, sir, whether you can correlate the whatever maybe the mathematics with your case studies. So that I have prepared this particular slide yesterday, right? Very slowly, within 5 minutes, I will explain you this particular. I will go through all these slides, but whatever may be the content is there with respect to the code, I will explain in the R environment. Okay. Yes. See here. Uh, Here I am going to explain Navy base algorithm, right, with respect to document classification. So yesterday I already explained you what is experiment, what is trial, what is sample space, what is sample point, right? Everything. So that I'm skipping all these things, right? Okay. But in Navy base algorithm, basically works on the theorem called Bayes theorem, right? Yesterday I explained you the Bayes theorem, that is especially the conditional probability P of A by B, that is the probability of an event A, right? The probability of an event A given that the event B occurred, right? With respect to some event, I'm going to predict the probability of another event. That is called conditional probability. So the Navy Bayes algorithms works with respect to this logic, right? Yes. Now I'm going to take the application called how to filter, right? The SMS, right? Short message service, okay? Whether it is a ham or spam by using Navy Bayes algorithm. So the first and foremost thing in any data analytics is collecting the data. So previously I said that either you can go for primary data collection or secondary data collection, but usually our community, our computer science community will only accept secondary data. That is, you have to work with only on benchmark data sets. So this is the site where I have taken this particular ham spam data set. Okay. I think everyone knows what is ham and what is spam. Spam means harmful message, and ham means it's a good message, healthy message. I can say like that. Okay. So how it works, the Navy Bayes, it is going to take the concept of word frequency, right? So how many words, right, which are going to be categorized as the nature of spam, or how many words are going to be there categorized as ham. With this logic only, this particular Navy Bayes, that is a condition. That is a conditional probability. So usually they have fixed this much of words comes under ham or spam. So when you take the new SMS, right, automatically depending upon the past event, it's going to predict the future. That is the background study of Navy Bayes algorithm. Okay, so these are all the content with each line of code. I will explain side by side, right, with R programming as well as with the slide information, so that you will have some better clarity. Okay. See here, Kumar sir, are you able to see my screen?
Yes, sir. Yes, visible,
Okay.
visible.
So dear participant, right now you are seeing my IDE of R Studio, right?
Sir, please little bit zoom it.
It's not Jupyter, sir. It's R Studio. I'm using R.
Zoom it.
Oh,
It's
okay,
not
okay.
visible.
It's not visible.
Not clear. Text is not clear.
Okay, okay, sir. Mm.
me close one
Now it
window,
is
sir.
okay, sir.
Little bit okay, sir.
So because I want to show all the result in 4 windows, sir. That's why I need all the 4 windows.
This is,
That's why.
it is full now, maximum one, no? Maximum size, no?
Yes, it is the maximum size only, sir. That's why.
Okay, sir.
See, dear participant, I think if you are having a very small font like this, you can pin. You can pin in Google Meet so that you will get some kind of projection, right? Okay, fine. So can I explain?
Yes, sir, continue.
Okay, okay. Don't worry, sir. I will show the each codes here in red color mark so that you will have some better understanding, sir. Okay.
Okay.
Okay. See here, right now you are seeing my RStudio IDE, Integrated Development Environment. So basically this RStudio comes with some 4 windows, right? You are seeing this is my script window where I can type my code, and this is my console, right? Where I can see my results, right? And this is my environment section where I can see all my variables, right? And what kind of memory is going to be occupied for all these variables. And this is a window which is very, very important for me to see all the graphs. And if I want to install some packages from here only, I'm going to install all the packages, right? See, the beauty of R is it's having some more than 15,000 libraries are there. And more importantly, the R programming, if you want to do some kind of statistical analysis, if you are very strong in R, then you can do wonders, right? So I will explain you everything one after the other. But here, similar to Python, right? Similar to Python, right? I have to first import some libraries for doing text analytics, right? So here, the most important library which is needed to perform text analytics is TM. TM is the library which is used heavily for doing text analytics. And some of the G models library I'm going to use for showing the word cloud graph representation. I'm using this library word cloud, and Snowball C is also another library which is used to perform some kind of computations. Okay. Yes. The first and foremost, I have to take the data set, right? So that is the thing I'm going to do. So I'm going to execute my code one after the other. Okay. So first line I'm executing. Yes, it is working. Second line I'm executing. Yes, it is working. Third line, fourth line. Everything is over. All the libraries are rightly installed in my environment. So no problem for me. Now I have to first take the data set. First I am taking the data set. The data set that I am going to take is a benchmark data set. I will show you the data set first in Excel so that you will have some clarity. So this is the data set. So this data set consists of only 2 columns. The first column is my label. So whether the text is ham or spam. I think everyone knows supervised learning algorithm. So here is my text. These are all my documents, I can say. Document 1, document 3. How many observations are there? I think hardly 5,200 and something row information I am having. And all these instances are labeled under the heading called type. So I am having 2 attribute. One attribute name is text and one attribute name is type. So this is my data set. This is the data set I am going to use it for my analysis. Okay. Yes. Now I am opening that file, right? Yes. It asking me. Yes, I am opening. Yes, I open. Now you immediately you will see in my environment that all the rows and columns informations are come to my RAM, right? See here, this is my variable SMS underscore raw, which consists of 5,574 observations, right? And 2 variables are there. I already told that type and text are the 2 variables. Okay, fine. If you want to see the structure of that particular variable, you can see by using the library function str. Yes, it is my structure. So the structure is a data frame. It's a data frame, right? You will see all the content, right? Okay. So next is I have to factor. Why I have to factor? Because see here, it is of type categorical in nature, ham, spam, like that. But I have to convert into numeric. That's why in order to convert the categorical things to numeric, you can use factor. So here two things are there, ham and spam. So one or two are going to be the numerics, going to be done with this kind of cases. I'm running. Yes. I calculating the factor. Now I'm showing, see here, it's a two-level factor is there. I think for ham it is representing 1 and for spam it is representing 2. I think in the console you will see the output. Okay. Yes. Now I'm showing the structure of this particular entire data set. Right. See here, out of this 5,574 observation, how many instances are having ham? That is 4,827 are ham, and 747 are spam. Okay, mostly you have to do all these kind of things before going to data analytics to check whether your data is balanced data or imbalanced data. All right. Okay. So with these things, I'm going to take only the textual information from my data set. That is, I'm going to create the corpus. Yes. Now I'm going to prepare the corpus. The corpus is created by using the function called vcorpus and vector sourcing function. So I created a corpus for the variable text in my data set. So if you just print the corpus, it will show only the metadata, right? Because it's a huge collection, that is 5,574, right? So around 22.7 MB of data is there. I don't know how many words are there. What is the dimension of my corpus? Very soon I will show you all these things. So I'm just inspecting, right? What about the first document? So the first document, I think it contains 111 characters. Similarly, the second document contains 29 characters, like that. You can just inspect each document by using the function called inspect in R, right? And the next I'm going to do some kind of what actually the content. You said that you are seeing only numbers, If you want to see the text, for that here I am doing some conversion as character. See here. So this is the first document. Go until Joran point, like that. So it's contain 111 characters. So now you are seeing that content, right? By using this function as character function, right? So now I am showing to the remaining 3 documents. For that I am using lapply function. See here, you are for the first 3 documents you are seeing. Now I am going to do all the operations that so far I have performed for a text document representation, that is lowercase, uppercase to lowercase conversion, stop word removal, root word finding, everything I am going to do by using the library function tm, right? See here. See, by using the function tm underscore map, right? I am taking that corpus, right? The corpus is created here. The corpus is created here. I am taking this corpus. I am going to do conversion to lower. Yes, I am running. Yes. Now my corpus is all the characters are converted into lowercase. Next, I am going to remove numbers. If there is any numbers over there in my corpus, I am going to remove. That is my 18th line. Yes, I removed all the numbers from my corpus. Next, I am going to remove all the stop words. So this is a function, right, to remove the stop words. Yes, I removed all the stop words. So the red color symbol seems that the machine is running, right? It takes some time, right? If the size of your data set is huge, it will take minutes or it may take hours also if you take high dimensional data, right? Now I am going to remove the punctuations, right? Yes, I removed the punctuations. And next I am going to do stemming, right? Removal of, finding the root words. See, if the screen is not visible, I am doing this one only. So this is the things for corpus, inspect, apply. These are all the things I already explained to you. So this is the text, right? Removing the numbers, right? So this is the code for removing the stop words, right? I already explained what is stop words and how to remove everything, right? So next is stemming, right? Stemming means finding the root word, right? Stemming is performed by using the package called Snowball C. That's why I installed Snowball C. So now I have to convert the representation. I said that is a document term matrix. Okay, see here. So after performing stemming and removing the white spaces also, right? Now I am in the stage to create the vector space model. So the vector space model using the concept of uh, inverse document frequency, right? But here I am going to use only document term matrix function, and I am going to give it to that SMS corpus. That SMS corpus is now cleaned. That means all the textuals are converted to lowercase, numbers are removed, stop words are removed, punctuations are removed. I already found the root words. Now all the white spaces are stripped. Now my SMS corpus is very clean. So with this corpus, I am going to do document term matrix. Yes. Yes. Now document term matrix is considered in the environment. You can see, right? Still, there are 5,574 observations of two variables. This is a matrix, right? That is, my matrix size is 5,574 rows and 2 columns. This is my SMS underscore TDM. That is a variable. Okay. Now, if you want to see that information, sorry. See, you will get metadata only because it's not possible to print the entire things, right? So if you see the sparsity is 100%. That means most of the entry of this matrix is zeros in nature, right? Okay. That's all about term document. Now the document is represented by using vector space model. So now the document is represented using vector space model. Yes. So this is the syntax. So this is the actual syntax for performing document term matrix. Okay. Okay. Now I have to prepare the data for analytics, that is for building the model. So for that, I think everyone knows that once a data set is given to you, you have to split the data set in such a way that some percentage of data should be considered for training and some part of the data to be considered for testing, right? The usual practice is there is no hard thumb rule. So I think here I am splitting it for the 80-20%. 80% of data is considered for training and 20% of data is considered for testing. So that is the thing I am going to right now do it here. Yes. Yes. And at the same time, I'm going to split the labels also. Yes. Now for cross check, I am doing some kind of prop table operation. See here in training labels, in training data set, the hams percentage is 86 and spam percentage is 13%. Similarly, I have to check this whether I am having the same thing with respect to tested data set also. So once if both are matched, then only you can say it's something you are doing some kind of justice in building a model. If it is going to be differ, I think the accuracy cannot be accepted by the research community. See here, for a prop table operation with respect to training set and test, right? More or less, both are more or less similar. That's why the model that I'm going to fit is good for me, right? So these are all the confirmation I can get, right? Side by side. Now I am going to visualize something related to word clouds. See in the right hand side, you are seeing some kind of, so the plots, just you are seeing the word cloud of my entire corpus. So what word clouds actually says, so the word which is having the higher size of font, that seems that word occurs more number of times in all these documents. A word which occurs with the word which is having a very smaller size font, which resembles that particular word occurs minimally in the documents. So that is the actual word cloud concept. Okay, so now I am showing the word cloud for the entire corpus. This is a word cloud of the entire corpus. So next I am showing the word cloud of the spam alone. Okay, this is for word cloud for spam, and this is the word cloud for ham, right? So now I'm going to do a very, very important thing that is called finding the frequent terms. So I said that there will be a lot of features will be there, So here I'm going to take only 5 words, right? Which is frequent in nature, right? So that words only I'm going to take and I'm going to filter from my corpus. So that is the thing I'm going to do right now. I'm filtering and I'm going to apply it to the document term matrix. Now the dimension is going to be reduced. Yes. Now I am using some convert function, right? That is used for converting the categorical things to numerics, right? For doing some analytics, right? Because I already told that with textual information, you can't do anything. For that, you have to convert into numerical things. That is the thing I am going to do right now. Now, by taking all this value, I am going to consider the train. It will take some time. Yes. Now I am going to do it for the test data set. Yes, I performed. Now I am ready to build the model by using Navy Bayes algorithm. For that, I am using the library E1071. Sorry. Yes, the library is in use. Now this is the this is the actual code for building a Navy Bayes classifier in R programming. Right, first you have to build the model. So after the model is built, by using this model, I am going to predict with respect to the test data set. Here I am going to build the model by using the training data set which has its own attributes. I will explain what is the Laplace mean by 0 and 1, everything. And similarly, after building the model, so you have to take that model and by using the predict function, you have to test it with the test data set. Okay, so that is the entire theoretical things related to Navy Bayes algorithm. So that is the thing I am going to do right now. I am building the model. Yes, the model is built. Now I want to test it. Yes, I tested. It is running. Still it is running. If it is a small data, okay, fine. So my model is built. Everything is there. Now I have to evaluate whether my testing is good or not, whether my model works in what level of accuracy, right? For that, I have to build a cross table. That is, I have to construct a confusion matrix, right? For that, I'm using the library functions, gmodels. Yes. Now I'm going to construct a confusion matrix for my model. Yes. So this is my confusion matrix. I think in this FTP, you are having a separate session how to evaluate the machine learning models. See, this is the confusion matrix, right? True positive, true negative, false positive, false negative, right? So now you are seeing, right? So 1,200 hams are rightly predicted as ham, and 20 hams are predicted as spam, and 9 spam have predicted as ham, and 161 spam is predicted as spam. So here the error is here. So 9 plus 20, 29. So that is my error. Okay. So with this confusion matrix value, you can find true positive, true negative like that. And with this thing, you can easily calculate the accuracy of the model, right? I will show you everything, but time is the only constraint for me. So now previously I built a model by using the Laplacian zero, right? Now if you want to optimize the model, right? So now I'm going to build another classifier with the same data set, but I'm going to change only the parameter. So previously I made the parameter Laplace equal to 0, right? If you are not going to give anything, it is initially assumed as Laplaciation equal to 0. But now I am slowly doing some kind of optimization. So see here. Now new model, another classifier is built by using Navy base. Now I am testing. It will take some time. Still it is running.
Sir, please share the PPTs and code also.
Yeah, everything I will share. So the content that I have prepared, not for me, sir, for the participant only, sir. I will share everything, whatever the things I'm having. Okay, sir. Okay. So why I have yesterday itself I will send the PPT of mathematics, sir, because once if the session is over, if I'm going to send everything to you, it will be easy for you to consolidate everything. That's why I postponed it. Okay. Okay. So okay, my second classifier also built. Now I want to check it. Right? Yes. If you see the second classifier, the confusion matrix, right? Surely some kind of improvement is there, right? So previously it is, see, previously it is in this confusion matrix, if you see, it is 20 plus 9. But here still it is moving. When Laplacian equal to 1, this algorithm behaves more error, right? Okay, some more error is there. So likewise, you have to optimize. Once if you know the basic ways to change the parameters, you can go for different interpretation. Okay, that is the thing I want to show right now. So next, there is another beautiful library function called caret is there for developing a ROC curve. Right? I think if you are very strong in building a deep learning or a machine learning model, finally you are going to show your result using this graph only, ROC curve, right? So here I have taken the values from the confusion matrix. I have taken the true positive value. From the matrix, I have retrieved true positive, true negative, false negative. Once if you know true positive, true negative, then it is easy for us to calculate the accuracy. The accuracy of the model is always true positive into true negative divided by true positive into true negative, false positive into false negative. This computation will calculate the accuracy of the model. Okay. So up to F1 I have performed. Yes. TPTN. So the denominator value. Now it is very easy for me to calculate the accuracy. So the accuracy of my model so far I have calculated is 97% of accuracy I reached, right? So this is one thing. There are several evaluation factors are there. Say for example, kappa coefficient is there, F measure is there. Otherwise, they will call it as F1 score. Precision is there, recall is there. So all these things can be calculated by knowing the values of TP, TN, FP, and the FN. That is true positive, true negative, false negative, right? So the error is 1 minus accuracy is my error formula, right? So the remaining things I am calculating, kappa coefficient and sensitivity also I am calculating. Specificity also I am calculating. These are all the various factors actually you have to do to evaluate your built mathematical model, not mathematical model, machine learning model. So I'm doing position, recall, everything. Everything is more than 80. That seems that the model is good. Okay. So that's all about up to F measure, right? So next I'm going to construct ROC curve for you. For that I'm using the library ROCR. Yes. So this is the plot function. Yes. I built the ROC curve. I am reaching the accuracy about more than 85, I think. If you want to really find out the area of my fit, right? Yes, for that I have to construct a AB line, right? So clearly the model is performing well. So this is the way in which I built a model for classifying the whether the message is ham or spam. Now what we can do further, we can experiment the same thing with the different algorithms, and you can do some kind of comparative study, or you can optimize the algorithm by changing some parameters. That is called hyperparameter tuning. Especially it is very helpful in deep learning, right? If you are come with a dropout, if you are going to come up with a, I can say optimizer, right? And some regularizations also. So there, this kind of optimization is going to play a very, very vital role, but not here in ML. Okay. That's all, right? So because of the time constraint, I am not explain line by line in detail. Sorry for that. Sorry, Kumar sir. So you have to know, right? Some kind of coding also. That's why I did all these things for you. Surely I will share all this code to you, right? So you just copy and run in your R console, right? Surely you will see the result. Whenever if you are having any, if you are encountering any errors, you just text me. I will try to solve that one. That's also I can do from my desk. So that's all. Thank you very much. I think I'm in time.
Yes, sir.
So now time is 11:24 in my clock, right? If you are having any questions in any area with respect to machine learning, deep learning, or mathematics, now the questions are open.
Yes, participants, you can unmute one by one and ask, or else you raise your hand.
Under any area you can ask me. If I am able to give the answer, surely I will give it. Anything from machine learning, deep learning, right? Mathematics. Go ahead.
Sir, can I ask you something?
So please,
That, you showed us two separate results. First time we got like 20%.
29. Okay.
The 29, and second day it was 35. So what parameter did you change? Could you please tell?
Laplace, madam. Laplace value.
Okay,
So,
sir.
I will send you the PPT as well as the code so that you will get you will go through the code along with my PPT, right? You will have a better understanding, madam. Okay. Due to the
Okay,
time
sir.
constraint, I'm not able to cover everything within 1.5 hours. Right, it's not possible for me. I think Kumar sir will understand this issue, right?
Yes, sir. Yes,
So 2 hours is needed for me to explain all the evaluation parameters, right? How to accuracy, error, precision, recall, kappa statistics, sensitivity, specificity, ROC, everything.
Yes, but it was very simple and easy to understand, sir.
Yes.
It was very good, sir.
Okay, thank you, madam. Thank you.
Thank you, sir.
So if you open any book, everything will be alpha, beta, gamma, right? I made to the core in a simplest fashion.
Yes, sir. Thank you, sir. Thank you, sir.
Okay, madam. Okay. Any questions apart from thank you? Excellent.
sir.
Any questions?
Sir, first of all, thank you very much for the excellent.
Okay, Saga sir, for you only I have made this particular
yes.
Presentation.
Sir, actually, my area of work is also like computational social science and basically recommendation system, where I have worked on some of the models like TF, IDF, and others. And
Okay,
currently,
okay.
I'm planning to work with that basically to develop a recommendation system based on that basically text analysis.
Okay, sir. Surely you can do.
Sir, once I develop the model, definitely, if you allow, then I'll be in touch with you and we'll be taking your advice.
Please
and
go ahead. We have to collaboratively, we have to work and we have to give it to the society. Surely,
Right, sir.
surely.
Right,
Whatever
sir.
may be the things, surely I will do it for you, sir. For you
Right.
only, I prepared all these things.
No, sir, it's my pleasure, and definitely, sir, my sincere like thanks and regards to you
Okay,
and
sir.
the organizer. Thank you, sir.
Okay. Thank you, Sarkar. Any participant, any questions, any specific questions? Even though it's general questions, I am able to answer. If not, I will learn from you. Thank you, sir, for sharing materials. Surely I will share my materials. What I understand
I
that
have a
CA and
question.
BA indicate any two documents. Sorry?
Sir, I have a question.
Yes, please,
Yes.
Anish.
Your voice is low, madam.
Madam,
You
your
can-
voice is very feasible. Can you please increase your decibel?
Sir, am I audible now?
Yes, now you are clearly audible.
Okay, sir. Sir, can you give me an example for text analytics, like a real life example? Like I have a doubt that in election campaign in US, was it the use of text analytics, using the
Madam,
tweets and all these things?
Anishka, madam, are you a student or a faculty, madam?
Sir, I'm a student.
Okay, Anishka. Anishka, you asked me a real-time example. So for the past 20 minutes, I explained only the real-time example, right? Say, for example, how to classify a message as a ham or a spam, right? When you open your inbox, some messages will be there in your inbox. That is ham messages only. And some messages are all...
I'm asking that in US election campaign,
Yes.
was it the use of text analytics?
Yes, you can
Like,
do
as in,
wonders.
sir,
Okay, I can say like that. You can go for social network, social media, social data analytics. I can say like that. Okay, say for example, if you are going to analyze the tweets, right, with respect to election, then you can come to kind of conclusion that what would be the state of mind of the people of US, right? So to whom they are. So the platform which is readily available to us is social media. Either you can take Facebook data, either you can take Twitter data, Telegram data, Signal data, wherever you see the text data, you can do analytics. Okay.
okay,
Sir,
thank you, sir.
Sir, will you please allow me to add something here, because I have worked recently on that. So I hope
Please
that
go
can
ahead. Please
can
go
help.
ahead. Knowledge is sharing.
Like, yes, sir and madam, sir, like recently, like you know that there was an election in West Bengal. So I, along with one of my UG students, we are trying to predict what will be the trend. Although you know that like without taking name of the political party, there were a different trend. Existing party were telling they will be in power again. Some of the new parties who are claiming they will be in power. So I, along with my students, during the February 7th and 8th, there are few hashtag has been formed in basically in like Twitter. So we have approximately extracted 2000 like tweets, and from there we have tried to understand that sentiment of the users there. And then we have seen, as per our analysis, we have seen that the result is going in favor of the existing political party in West Bengal. So we have communicated the paper to one of the IEEE sponsored conference in Kerala, that is the Government Engineering College of like Iduki. They have appreciated the paper a lot, but then they were looking for that basically the validation. And we did not have any such proof of validation, but we are lucky in that sense that they have given us the time to incorporate the validation by 7th of June. And if you can remember, the result came out with Kerala and West Bengal in 29th of May. And we know that what was the result. So our result analysis also was telling the same thing. And I'm happy to share that our paper got accepted. So from here, I can tell that the same example that you have cited, that we can extract the data from Twitter, we can analyze it, and then we can do different kind of sentiment analysis, recommendation system, and other things. I hope I could add something.
Thank you, sir.
That's also a
Thank you.
wonderful real-time example.
Vijay Gopal asked one question. What I understand is that AI and BI. BI means you are asking business intelligence, sir?
Who is
I
that
don't.
name?
Sir, Vijay Gopal. At the time
Vijay
of
Gopal.
10:55.
No, sir, it was cosine
It was
cosine
an
similarity part.
Okay. Oh, there is AI documents. AI BI. Okay. Any two? Yes.
AI
AI
means
BI means any two.
document.
AI documents only. I thought that AI means artificial intelligence. BI means
Yeah.
business intelligence, like that. Okay. Thank
Documents
you. I think some participant clarified that one. Thank you. I think you are very tuned with my lecture. Thank you.
And one more is there, sir. Last one. Any website to learn deep learning and NLP?
Sir, say for me, we have to explore everything and we have to find out one thing. So there is no website according to my understanding, and at the same time there is no one book which covers everything deeply and correctly, right? Some concept will be discussed by one author in a very nice sense in one book, but the other concept we can't expect the same thing, right? So like that. But if the participant asks, I will give only the list of books, but in a single book or a couple of books or 10 or 5 books, it's not possible. We as a researcher, as a learner, we have to read all the books. That is my understanding. I think you accept, right? Whenever if you are having some kind of books with respect to ML or DL, just read everything so that you can refresh your ideas also. So whenever you are having some kind of mathematics books, open it and read it. That's all.
Okay, participants, if you have any doubts, you can text to the Kumar Veran, sir.
Okay, any website. If you're asking, then there are several websites are there for me. Kaggle, I think now actually a 30 days course is going on in Kaggle, right? Towards data science, you can go for, right? And Medium Digest is there. Okay, I will text you everything, sir. Okay, sir. List of websites. And if you really want to do R programming, R blogger is there because I am the active member over there, right? So whenever you are encountering any kind of an error, or if you are not able to complete any particular project and you are in the middle of the stage, right? In R programming, you are encountering some kind of an error. So surely that particular community or blogger, they are providing wonderful result, right? They are helping to complete the project. There are several things are there, several forums are there. I think participant, I served my business. Kumar sir, is it okay?
Yes, sir, very good.
Because you've given me 3 sessions, I don't know how the participant reacted. Okay, if really students, please take this thing seriously. Surely, if you are going to choose your career as a data scientist, surely you can come up like anything, right? So for that, please have some mathematical background. So without mathematics, it is not possible. And at the same time, if you want to be a researcher, if you want to show your result, right? Once if you show it in terms of an equation, then only the community accepts. Okay, so just not by typing the code and getting the result is not important, right? So need more lecture. Okay, dear, if possible, right? Thank you very much, sir, Kumar sir, for giving me
Yes,
this
sir.
opportunity.
Thank you,
My
sir.
throat is paining like anything,
Yes,
right?
sir. Yeah. You
Okay.
are speaking last 1.5 hour continuously.
Yes.
Thank you,
Okay.
sir. Thank you very much.
Okay.
Rahman, you will continue, Manas.
Yes, sir.
So can I leave?
Wait, sir.
Wait,
Okay.
sir. So it was a nice lecture, sir, and it will be a beneficiary for all the PhD scholars and lecturers also. So I would like to invite Mr. Radish Raju to show our great gratitude towards sir. Radish, sir.